A very good morning. Myself Kranti Gaurav. Today I am going to teach one of the most conceptualized topic of the operating system, that is process synchronization. So let me start. Firstly, brief overview what we will study today. Firstly, process synchronization, then race condition, then critical section problem, then solution to critical section problem, two process solution using turn and flag variable. First, now when two processes occur at the same time, they are called concurrent. Okay. When two processes or many processes are synchronized, occasionally they are called asynchronous. Similarly, when two or more processes are synchronized frequently and the relative order of execution is guaranteed, then they are called synchronous. When processes have no relation with each other, they are called independent. Now, race condition. It is a bug where the outcome of the concurrent threads is dependent on the precise sequence of execution. For example, there are two trains, okay, and they want the shareable track, single track at the same time. So what will happen? We have a collision. So to remove this, we have a different type of procedure or protocol that one train will come at the same time, one will be stopped. So this is the thing. Similarly, we will see here that we have a critical section in which we put one process and other will wait unless and until it will complete its execution. So similarly, we will see what is critical section. Critical section is the region of program that try to access shared resources and cause race condition. Okay, so this is the critical section. Now, how this critical section will be implemented, how the process will come and go, this is the critical section problem. This is what is called critical section problem, and what are the ways to design a procedure. Okay, now what are the assumptions for the designment of that protocol? Firstly, there will be no assumption about the hardware instruction. What are hardware instructions? We don't know. No assumption about number of processors supported, how many it is, multiprocessor, uniprocessor, or something else. We don't know. Basic machine language instruction executed atomically. This is the assumption that all the instructions should be executed one at a time, atomically. Okay. Now, there are three criteria which every solution must follow, so that we can say that this is the solution. Firstly, mutual execution. It means that at a point, one process should enter in the critical section. There cannot be more than one process in the critical section at a same point of time. It is the mandatory criteria and it should follow. Okay. Second one, progress. It is also a mandatory criteria. In this, if critical section is empty, suppose there is no process in the critical section and any process wants to enter in the critical section, then there must be no restriction. Okay, there will be no restriction for that, so that it will go in the critical section. This is the second. It is also mandatory criteria. Third one, it is an optional criteria. It's called bounded waiting. In this, we say that there will be a number of bounds, so that in the critical section entrance of process which will enter the critical section should have how many times will enter. So it is basically an optional criteria. It means that when suppose there is a process, it goes into the critical section, comes out, then again goes into the critical section, then again comes out. So we have to bound the number of times any process should enter in the critical section. So this is optional. Further, when we go to the solution, we will only focus on upper two criteria, mutual exclusion and progress. We will not look into this criteria. Now, solution. What are the solutions? First solution, it is a software solution. It means the algorithmic ways of solving the critical section problem. We design some algorithm procedure and we will solve it. Hardware solution, we make the processor such that it will assess the critical section atomically, or all the criteria which I have discussed earlier should be fulfilled by the hardware type itself. It means when we design our system, we will solve it. Third is semaphore solution. Semaphore is basically an data structure. Okay, so this data structure which used have some two operation like what we say wait and signal. With the help of this signal, we will solve the critical section problem. Now we will focus on the software solution. This is the general solution. Okay, this is general solution. There is a PI. PI means any number of process, whether P0, P1, you can simply understand. So now here we have entry section. This entry section, in this we have some condition. With the help of this we enter into the critical section. Then we have exit section. So after this section, critical section work is completed, and this is the remainder section. Here we have no relation with the shareable resource. This is all the private resources which the program has. Okay, for example, suppose in home we have TV, we want to see any channel, so it doesn't affect any other people and what you are watching on the TV. But when we go outside and we want to acquire the public transport, so we cannot make it for our personal use, that when we want it will come into the bus stop, and when we doesn't want it doesn't. So this is same thing about this. Critical section means what are the shareable resource. Here shareable resources are used and these are work. Now first solution. Okay, this is the first solution. Okay, is a two process using turn value. Turn is a simple variable. Okay, initially we make turn 0. Okay, initially turn is 0. One thing you have to note, there is note any process can be context switched at anywhere and any time. This thing must be taken in mind, that any process can be context switched at any time and anywhere. I am strictly focusing on this thing. Any process can be contexted. Okay, now let me start. What will happen? Firstly, initially turn is 0. This while 1, this is a true loop. Okay, now while 1 it goes there. Now see this line, while turn is not equal to 0 and semicolon. This is a loop. This is an empty loop. There is nothing in the entry, there is nothing after that loop. So what will happen? We have, this is actually a trap. How? See, now here turn is equal to 0. What is this? Turn is not equal to 0. This is false. So when this is false, what will happen? We will goes out of the loop and goes into the critical section. I am repeating again. Okay, see, when turn is equal to 0, this condition is what? False. So we comes out of the loop and goes into the critical section. Okay, this is the main concept. This is a trap. Okay, it's a trap. So we use this trap to go into the critical section. Now it goes into the critical section. Now what we will do? We context switch here. Here we context switch. Now we have to check whether the other process P1, what can it goes into the critical section now. Let me see. This is true anytime. Now while turn is not equal to 1. Now this condition is true. Now when this condition is true, it remains in the loop. Understand? It remains in the loop likewise. So it will not go into the critical section. Okay. So from this what we can say? It satisfies our this criteria, mutual exclusion. It means that when one process is in the critical section, another process cannot enter in the critical section. Now after that it make the turn is equal to 1. Okay, and comes out. Now when turn is equal to 1, this condition becomes false and this goes to the critical section, and this goes and perform all the operation in critical section. Now the question arises whether this two process solution using turn variable show progress. Let me see. Suppose while turn is equal to 0 it goes, turn is equal to 1, and now this turn. You can see one thing, there is a strict alternation. It means that when this completes, it must go. Suppose this completes, okay, P1 has completed. Now P1 again want to enter in the critical section, then can he enter? No, he doesn't, because turn has become 1. Okay, now turn is not equal to 0. Okay, so this condition becomes true, and this again goes into the infinite loop. So this is the strict alternation. Sometimes question has been asked about this turn variable. So it is a strict alternation. Means actually anytime we haven't asked process that are you willing to go into the critical section? No. So this solution doesn't satisfy progress. Okay. Now we will look into the new solution. Now it is with the flag variable. Now flag variable. In this we have used a flag variable, which is initially we have taken. It is actually a Boolean variable, so we have taken all the false for both. Okay. Now let me start with P0. Initially both. Now come here. This line is true. No problem. Now it comes here and flag 0 is equal to true. So it makes it true. Okay. Now what will happen? While up now what he will see whether P1 wants to enter in the critical section. Now this is the trap. Okay. While flag 1, if this flag 1 is true, then it will not go into the critical section because another process is wanting to enter in the critical section. Okay, so from this at this time this is false, so no problem, it will go into the critical section and no problem. Now suppose we context switched here. Okay, now goes to this while 1. Now flag 1 is equal to true. Okay, now we make it true. Okay, now this is true. Now while flag 0, if this condition is true, it will go to the, now you can see that it is true, so it goes into the infinite loop. Okay, so it doesn't go into the critical section. Now when it complete, suppose this is now flag 0, it again make it what? False. So now this condition will become false and it will go into the critical section and perform. So it again satisfied mutual exclusion. Now we could see whether it satisfies what? Progress. Okay. So suppose again this want into the critical section. Once it has completed, it is true. Okay. So it will go. It will go into the critical section and perform its operation. Now you will see one more thing. Suppose if we make both these false. Okay, we will make both these false. Now go here. Flag 0, it makes it true. Now it is true. Okay, now again it comes here. Now we context switch here. Okay, now we go into this and it also makes true, because I was always saying that any process can be context switched anywhere. So here this is true and this is true. Now there will be a deadlock. No process will go into the critical section. This condition will be true and this condition will be true. So it also doesn't follow progress. So this is for both the solutions. Thank you.